Okay, in this video, let's talk a little bit about security. This topic stretches a little far and wide, and I don't know if I'll make it through everything, but we have multiple aspects to look at. Security in the way of the design of the deployment, when we talk about where exactly in our network to place our Silver Peak SD-WAN devices. Security features built into the Silver Peak product itself, like its firewall and in new versions, IPS IDS. Security integrations around the product with services like zScaler and Netskope, some of the SASE functionality. I won't get to every nerd knob and geek whistle here, but hopefully we'll touch on a lot of it. So let's look at my lab network. We can see this is basically a migration from a legacy hub and spoke MPLS type solution. There are no firewalls at the branches. The major change we have here is in the way the internet traffic is processed. In our hub and spoke, it would all have gone back to a data center and dropped out through a data center firewall. Now, we can still do this with Silver Peak. I could put in a firewall at any one of these sites, tunnel all of the client internet bound traffic to it and out to the internet through that firewall. Not a problem, and works just fine. But here we have our core switch and router, the Silver Peak, and then the internet. Our current setup, the way that it's configured right now, the client internet traffic is simply going through the Silver Peak and has basic stateful firewall getting NATed direct to internet. So nothing in the way of what I would refer to next-gen IPS IDS content malware inspection in any of those next-gen feature sets in place right now. But we've got these new internet circuits at each site which didn't exist there before. So in a migration, we ended up saving a boatload of money, moving away from the traditional MPLS to internet-based SD-WAN. Why not also utilize these circuits for our internet traffic as well? In addition, what about our corporate traffic? Do we need to firewall that? Did it have a firewall before? Do we need inspection on that traffic? What options do we have? Let's take a look at a few of those. I'm going to jump over to a basic lucid chart diagram here. And as we've seen in previous videos, the Silver Peak does have a stateful firewall built in. We can utilize it in our topology. It might be better than what we had before in the way of wide open hub and spoke routing. So we've perceivably got 3 VLANs at our site. VLAN 10 for data, VLAN 20 for voice, and VLAN 50 for guest. Now, if we want, we can certainly throw in a layer 2 switch and simply drop those VLANs to the Silver Peak, either on a trunk or individual LAN side ports. In this scenario, we can put in a firewall policies on the Silver Peak to allow traffic between these, to and from the internet, etc. In this case, all of our routing is done on the Silver Peak as well. Being we don't have any routing coming in from a LAN side BGP OSPF routing instance, we'd be looking at putting these in as static routes or advertisements for the SD-WAN. We'll take a look at the configuration of all of this a little later in each different scenario. So, out with our layer 2 switch, in with a layer 3 switch. This is essentially how I have it set up in the lab today. I have a BGP relationship between the Silver Peak and the core switch, and off of the core switch I have my routed VLANs. They have a default gateway on the core switch. It has a network between it and the Silver Peak that adjacency is formed on, and all the traffic gets sent up to the Silver Peak. And in this case, traffic destined for another site with Silver Peak based on routing would go over the tunnels. Internet traffic just gets NATed out to the internet and on its way. In this case, I can still achieve my goals with firewalling utilizing a rule set, but we'd have to keep some things in the same zone, being that we apply the zone to an interface. Now, we could certainly have our data and voice VLANs routed and the guests come into a separate Silver Peak interface or VLAN sub-interface. I have customers doing that now, and it works well. All of the corporate traffic is core routed, and the guest is dumped layer 2 to the Silver Peak. Silver Peak handles the guest network's DHCP and other network supporting services. And of course, the same firewall policies we've been talking about would apply to make sure that this guest network doesn't get routed over to the corporate network and stays separate. But what if our requirement is that all the traffic has a next-gen firewall solution with IPS, IDS, and the bells and whistles? Well, on the latest versions of Silver Peak, we have that as well. We now have some IPS, IDS solution that we can put in place. But what if our sites already have next-gen firewalls? What do we do with them then? How does Silver Peak play into this? Where do we put it? In front? Behind? Beside? First, pretty much any scenario is valid and supported, but there are a number of things that make a certain deployment make more sense. So first, let's assume our site already has a firewall today. It's connected to the internet and to the core, and we're just using site-to-site VPN maybe rather than our previous design conversation around legacy MPLS. Let's say this is a Palo or an FTD or a FortiGate or some other brand of next-gen firewall that actually does all of the next-gen feature set. The firewall connects to the core switch. Time to move to Silver Peak. What do we do? As I stated, we can put it anywhere and it's supported. So in this scenario, we'll go ahead and move out the Silver Peak and set it beside. Our internet circuits would be coming into this firewall today. It of course drops into the core, and back here lives all of our clients and their relative VLANs. So now I have some options here. Do I put the Silver Peak here and sandwich it between the firewall and the core? Do I put it over here beside the firewall? Do I put it up here in front of the firewall? Let's talk about each of those scenarios. First and foremost, if we were to put it behind the firewall, the first thing we notice is all of the traffic would route from the core into the Silver Peak or drop direct into the Silver Peak if it was going to replace a layer 3 core. Either way would not affect the outcome. That traffic would then route up to the firewall, and the firewall would send it to the internet if it's internet-based traffic, or send it onto the sites. The difference here is that when the Silver Peak builds its tunnels to the other sites, those tunnels are going to be encrypted IPsec tunnels. In that scenario, the firewall would never see any of the corporate traffic coming through the Silver Peak. All it would see is the IPsec tunnels to the other sites. So we lose visibility into that corporate traffic when we do this. So what if we decide to put it beside the firewall? Well, again, a valid option. If we happen to have enough public address space here, we could certainly bring these ISPs into this firewall as well. We could connect this direct to the core and connect this direct to the core and let Silver Peak advertise routes into the core that it's learning about from the other sites. However, again, we've lost visibility to that corporate traffic. Internet traffic would go out the firewall just like it always had. Corporate traffic would go to the Silver Peak and on its way and completely bypass the firewall. In addition, we of course have to have the appropriate number of usable public IP addresses to support this as a solution. So what if we did have enough and we still wanted to be able to see and inspect that site-to-site traffic? Well, we could also take this and set it off of somewhat of a DMZ interface of the firewall and either create that OSPF BGP relationship here so that the firewall knows about all of the corporate routes that are being learned, or in some scenarios we simply in the firewall route all RFC 1918 address space over to the Silver Peak statically. We've achieved our goal. This comes up, it hits the firewall, it would head over to the Silver Peak and on to its destination. If it was internet bound, we go to the internet. We've accounted for all the traffic. However, with this scenario, in any side-by-side scenario, as we talked before, whether this goes to the LAN or whether it goes to the firewall, we have another issue that comes up. Silver Peak uses what it knows about these circuits to make decisions on which circuit to send traffic down based on utilization, latency jitter, etc. So in this scenario, we end up with somewhat of a ships in the night issue, where if someone down here on the data VLAN is doing a large download and completely swamping the ISP1 link, my Silver Peak never knows about that. He'll never see that traffic. He won't know that this link is indeed saturated. So from a utilization perspective, this can indeed cause issues for the way that Silver Peak is handling the traffic and using what it knows about those circuits to deliver it. So what if we pull the firewall down and slipstream the Silver Peak up in front of it? This, I will say, is the recommended design. In this scenario, we have achieved our goal as well, right? All of our traffic, whether it be internet-based or corporate-based, is going to go through the firewall. It's going to hit the Silver Peak and go on to either the internet or to other sites via the SD-WAN. Now, I can see the firewall admins already cringing looking at this, saying, no, historically and always, my device faces the internet. Nothing goes in front of it, unless it's a switch for some breakout or whatnot. No layer 3 device, so to speak, goes in front of it. I'm a firewall guy too, and when I first saw this design, I thought the same thing. That doesn't make sense. You know, now what's my firewall doing? Well, at the end of the day, it is just doing firewalling. We essentially disable NAT on the firewall and let it do firewall things. Traffic comes in, goes through the policy set, the inspection, etc., gets thrown out to the Silver Peak. The Silver Peak then sends it on to the internet and or down to another site across the SD-WAN. The big difference in the shift in life is that we're no longer doing any natting on the firewall. It gets done on the Silver Peak. Now keep in mind, this is branch office design, right? Not data center design. Silver Peaks in the data center, in a lot of cases, are in that side-by-side mode. They have to be, right? We've got services being hosted out of the data center that need inbound NATs, web servers, mail, etc. Not that we can't do that here. The Silver Peak definitely supports inbound port forwarding. In this scenario, we could inbound port forward something to the firewall and make it back to a server back here on the LAN, and it would work just fine. I've done it a number of times. But this is really targeted more for the branch office where we're not hosting services. If we have a port here or there that needs forwarded through, not a problem. However, if we're hosting, huge data center services and whatnot, again, different design typically in the data center. And then in this design, we don't really need the firewall capabilities on the Silver Peak at all. We don't really care what would happen to make it through to the LAN side, right? It's going to hit the firewall anyway. Either it was already blocked on the way out in the case of content filtering, etc., or if it was a packet that happened to make it through somehow, the firewall should take care of that right away. In the end, we simply moved our NAT boundary up to the Silver Peak. Now, this also alleviates the issue we just referenced, where the Silver Peak gets to see all of the throughput on both of the ISP links, and we don't have any ships in the night, so to speak, where it wouldn't be able to account for traffic. So last situation now, we've turned the corner in a lot of areas to a SASE-based model. In this case, we'll go ahead and just get rid of our firewall at the site. We'll bring the SD-WAN back into the network. Again, in this model, would not matter whether this was a layer 2 switch, layer 3 switch, and we were doing firewalling, routing, etc. on the Silver Peak. In this scenario, using tools like zScaler or solutions like for a SASE-based, cloud-based firewall, again, Prisma with Palo or other Netskope, we would ultimately end up setting up GRE IPsec tunnels from the Silver Peak out to zScaler, and in this scenario, the traffic coming in SD-WAN, no difference, no change, would be going to and from. Now, do we have that next-gen feature set here? No, other than, again, up-and-coming feature set being provided by Silver Peak with their IDS IPS. Otherwise, all of this traffic, internet-based traffic, is going to go ahead and get shot out to zScaler, dropped out to the internet, and all of our next-gen firewall services would get handled with zScaler or whatever SASE provider we chose to roll with. The Silver Peak solution we'll look at later has some awesome integrations into a number of these SASE-based providers now. I would love to be able to look at that in lab. However, back to my previous rant in the first video, getting licensing for any of these cloud providers is darn near impossible. To be able to set up these tunnels and show how that would work, I can somewhat show the configuration and what we would do to set that up and how it would work, but outside of that, that's about as far as I can go. So let's jump back into the lab and show some of these scenarios in the firewall configurations. What I've done here is I have removed the existing VYOS and Linux box, the router and the Linux box, from our West site, and I've replaced it with an Aruba CX switch, virtual switch. So this switch is a basic config, no layer 3 routing, just a layer 2 switch. If I do a show VLAN here, you can see I've created our data, voice, and guest VLANs. Port 1 is data, port 2 is voice, port 3 is guest, and then port 16 is this trunk port that comes up to the Silver Peak. So this Linux box over here is going to be simulating our data, corporate data traffic, this one our voice, and this one guest. So in the background, we will jump back over to Orchestrator here. And you'll notice we picked up a couple of BGP alarms here because I did not delete that config. So I've pulled up the deployment tab, I'm going to edit this, and we see our LAN side interfaces. Now I'm going to leave this, right? This is native VLAN, there's no number here. So I'm going to go ahead and leave this alone, and I'm going to go ahead and create some VLAN sub interfaces for 10 our data, 20 our voice, and 50 our guest. Then I'm going to assign them some fictitious subnets here. 76.1, 77.1, and 78.1. And because I'm lazy, and partially because I want to show this feature set, we're going to go ahead and enable DHCP on these interfaces as well. So 76.0, start address of 10, end address of 20, let's give this a random 8 hours. You can see most of the typical DHCP configuration is here. We can add options. We can add static reservations or assignments. Get the second one done. 77.0.24. 7.10. Whoops, that's 6.20. Here. I've forgotten to check that a number of times. It'll let you configure it, but it won't turn it on. So 78. Well, that didn't work very well. Next to be 0. Okay, so now we've got a DHCP server enabled on all of these as well. We'll go ahead and save this. And again, as soon as I do, you'll see it. Just pushing that out. Now that that's pushed out, with any luck, I'll be able to jump over here, boot these virtual PCs, and we should be able to get a DHCP address in the relevant VLAN. So as soon as these guys boot, I do IP DHCP. It's going to go ahead and try to request an address. And there we got one. This guy should get 7710. Nope, 7711. Okay. Then this guy. Oops. $78.11. Good. So now what we'll see here is we should, at this point, being we haven't done any firewall work, be able to ping back and forth between any of these, and specifically over to the guest PC. And we can. So traffic is indeed routing through the Silver Peak. So what about traffic to the other SD-WAN sites, right? If I needed to be able to get over to, say, this router here, 104.2, can I do that? I certainly can. And why is that? That is simply because in our routing template that we put in, we were allowing local routes and advertising the local LAN side routes. So when I look at the config here, this route map that we pushed from template is indeed allowing BGP and local, and we've got automatically advertised local LAN subnets. So if I look at any one of these other appliances and look at their routing table, what I'll see here is instead of learning that via BGP somewhere, it just simply states that it is learning it from the device itself. So here we are, 77, 76, and 74, which is our previous BGP subnet, and then 78. So now, what if we don't want voice to talk to data and guest to talk to voice or data, etc.? Let's take a look at that. If we come over here to firewall zones, You can add a couple of zones. Let's call this data. Let's call this voice. And let's call this guest. Now that we have those zones created, we should be able to come to our firewall zone security policies. Click on our relevant Silver Peak here. Click Edit. And when this pulls up, we should see all of our zones, and it is a true zone-based firewall. So by default, we allow zone-to-zone traffic, right? So for whatever reason I had two subnets in the data, they would be able to talk to each other, route to each other, etc. Same with voice, video default. In our scenario here, we're not using the default for anything. So I can come in here and I can say, hey, I want to deny all of the traffic from default to data, or voice to data, guest to data. And by default, you'll notice these are set to deny. So I didn't have to do anything. By default, this is the way that it's set. So I've accomplished my goal, and I didn't really have to do anything here. If I go back over to my deployment, I now should just have to assign the firewall zone. If you remember or go back in the video, this did not exist anywhere. And I can assign data, voice, and guest. Save. And while this is applying, one other thing I wanted to show you here is with the DCP, we can also go look at leases, right? So here we see our 3 active leases as well. And now that that configuration is pushed, if we come back here again, let's try to ping 104.2. Well, we can't. Let's try to ping 77.11. We can't. 78.11. Whoops. And we can't. What about 78, excuse me, the internet? Well, we can't. So we locked it down good. They are locked down to their local subnet. So in this scenario, what we're running into is we can no longer ping any of the other sites because they are all using the default policy. In addition to that, so is the internet, right? On our internet side is in the default. So I would need to then come here and say default to data, add a rule, allow, add a rule, allow, add a rule, allow. Then we need to keep in mind that this is also bidirectional. So I've allowed from default to data, to voice, to guest, but I have not allowed from data to default. So in this scenario, I need to do the same thing down this side. Save this. You notice it kind of lists the rules in a more table view here, where we see the default segment, from zone, to zone, match everything, and then the default deny, as with any access list, with a higher priority in that list. So now if we jump back over to Eve, we should be able to ping across our SD-WAN. We should also be able to ping to the internet, but we should not be able to ping our neighbors here. and the voice and the data. And of course we can't. So we have locked that down in this case where these three networks, our voice, data, and guest, can get to the SD-WAN and to the internet, but they cannot talk to each other. However, we now have an issue here where our guest traffic can indeed get to the other SD-WAN corporate, right? It can't get to our local corporate, but it's still being allowed over to the rest of the SD-WAN, simply because all of this is still in the default zone. This obviously isn't preferred, so let's take a look at that. This would be where we get into the additional facets of the rules here. I need to make sure that anything coming from guest cannot get to my corporate resources that are in default. However, the internet is also in default. So a number of different ways to slice this. I could create another zone and move all my corporate resources into that as a net new zone, or I could get into the additional facets of the firewall rules here. If in my network all of my corporate resources are private address space, and I know that these guests should never be able to get to any private address space, as it should be internet only, I can come in and modify these rules so that those subnets are no longer allowed. We need to keep in mind, though, that these are bidirectional rules. I can simply block it on the outbound and leave this allow everything, or I can do it in both directions. In this case, I'm just going to say from guest to default, I want to add 3 deny rules. And I'll make this 10, 20, and 30 to put them above that 50 of my allow all. We'll set these all to deny. And in here, we will set this. So if I'm coming from my guest network and my destination is the 10 dot private address space, deny it. Yet again, if I'm coming from and my destination is 12, deny it. And if I'm coming from my subnet, oops, to that private space, I deny them. Now, when I save this, what we'll see is it did reorder them 10, 20, 30, and 50. So we're denying from my subnet to these private address spaces, then allowing everything. Very typical access list type deployment here. And in the future, I could modify this if there were some DMZ hosts or something that I need these guests to get at. I, of course, could put permits above in the sequence to allow that. So now if I come back over to Eve, let's make sure I'm on the right machine. Should be 7811. Yes, so here I can ping 8.8.8.8 across my SD-WAN. I am denied, and of course I'm still denied from my local networks here as well. So now I'm a true internet only on the guest side. So I've successfully got that taken care of. One other thing to note, as we went through templates earlier, I can, of course, come back and create a template that would assign policy to multiple devices. So under configuration, templates, if I just pull this firewall or security policy over here, you can see I get a very similar look and feel. So I could configure this up as the same across the board and apply it to other Silver Peaks and save myself a boatload of work having to manually configure this. Now, keep in mind, I would have to modify my rules a little bit, because in my rule set here, I did do this based on the specific source IP of the guest network at this site. I could, of course, set this back to any, and that would then fulfill the need for all of my sites if that was a valid use case model. So in here, if I edit this guy, set that to any with the destination only, that would also do the same thing in this scenario. So that kind of covers off on how we would use the firewall local to the Silver Peak to deny traffic between zones, subnets, etc. Again, kind of a cool little policy for the zone-based view here, to and from, and all of your rules can go inside the different zones. So that pretty much wraps it up for the zone-based firewall portion of the configuration. Next thing I wanted to show you quick was the new IPS IDS. Now, I can't show you a lot here. I'm not licensed for it, but I did upgrade one of my appliances with enough CPU and RAM to show that here we can enable it. If I click apply, I've got options for off, IDS only, or IPS performant. I can apply that there, and unfortunately that's about all I can show you here. We can see all the signatures and search them just like a next-gen firewall would in that scenario. And lastly, in the security video here, I wanted to talk about some of the integrations with SASE. So over here we can kind of see the AWS Checkpoint, Microsoft Office, zScaler, and specifically on the zScaler piece, when I come in here, I can of course connect this up to zScaler and push and configure all of my zScaler tunnels and information, sub-locations, etc. right from here. It will configure the ZIA cloud with all that information. So very cool integration. I've used it a number of times and works very well for SASE.